Hello, today I'm going to look at how to apply the trapezium rule. I'm not going to do coming up with the trapezium rule, just how to apply it to a question. So we use the trapezium rule for estimating the area between the graph and the x-axis. So here I'm looking for the area between my b value and my a value. N is going to be the number of trapeziums, or the number of strips. And we get the trapezium rule as the area, well, we write the area as the integral of f of x. All you need to know for now is that this means the area between a and b. If you've not met integration yet, you will do shortly. And this is equal to a half h brackets y0 plus yn plus 2 lots of all the y values in the middle. So y1 plus y2 plus y3, all the way up to the last y value, which isn't yn, so yn minus 1. If anything goes wrong in the trapezium rule, it will be because you've missed out brackets. That's normally the main problem. What you'll notice here is we need to calculate our y values and we need to calculate an h value. To calculate the h value, we use the formula h, or h is the width of my trapeziums. So the trapezium rule is imagining dividing this into trapeziums, and we're finding the areas of each of these trapeziums. H is the width. It's how much we're going up between our x values, and that is given by the last x value, take away the first x value, divided by the number of strips. So let's have a go at applying this to a question. The first part says sketch a graph of the equation p equals 31t minus 5t squared. So this is really an algebra question. So you need to think back to our AS work. We know that we're going to have 0. This factorizes, which helps us a little bit. This factorizes to t brackets 31 minus 5t. So I know that because it's minus t squared, it's an n-shaped graph. And this point here is going to be 6.2. So my graph looks like this. Part I asks you to find the maximum value. I've skipped that, but you would also indicate the maximum value. State one problem with using this model. Well, past 6.2, we're into negative numbers of people. And T is the number of people in thousands visiting the shopping mall. We can't have minus thousands of people visiting a shopping mall. Past our 6.2, it's not going to work. So let's get on with the trapezium rule part. Use the trapezium rule with 4 strips. So this 4 strips is telling us that our n value is equal to 4 to find an estimate of the total number of people who entered the mall in the first 4 hours that it was open. So we're looking for up to 4, up to here. We're after this area. And we're going to use 4 strips. So we're going to divide it into 4 parts like this. So the first thing that we need to do is we need to work out what our h value is. In this case it's t, but normally in our formula we're thinking in terms of x's. What these steps along the bottom are going up in terms of. And to do that we know that h is equal to my last number minus my first number. Well, because we're starting from the beginning, it's going to be 0, divided by the number of strips, which is 4. So h is very conveniently going up in steps of 1. The first thing I want to do after finding h is to do a table. And here we're going to have n, we're going to have t, and in this case we're going to have p. This is my x value normally, and this is my y value normally. We start with 0, 1, 2, 3, and 4, because we've got 4 strips. My t value starts at 0 and it goes up in ones each time. And now I need to calculate my p values. Okay, the best way of calculating our p values is to use the table mode on our calculators. So we're going to switch our calculators on. And then I'm going to go to my table mode. So on these calculators it's 4, I'm just going to type in the equation as it is there. So 31t, well, this is going to be x because our calculator does y and x, minus 5t squared, so minus 5x squared. Then I need to tell it what my range is. So I'm going to set, and I'm going to start at 0. I want to end at 4. I want to go up in steps of 1. So that's all fine. Now I press table, and you can see that my calculator has given me the values that I'm going to write into my table. So we get P as being 0, 26, 42, 48, and 44. Now to approximate the area, I'm going to use my equation. We know that my area is equal to a half h, curly brackets, round brackets. Now these are really just round brackets twice. I only use curly brackets so that I can see where they open and close. y0 plus yn. So that's my first term and my last term plus 2 lots of all my middle terms. Well, these are going to be my middle terms, y1, y2 and y3. And then I close with my curly brackets. So you can see here, it's nice and clear to see where my brackets open and close because they're curly. That's the only reason we use them. On your calculator, you're just going to use round brackets. Now I can substitute numbers in. We've got a half. H, because we're going up in steps of 1, is going to be 1. And then my y0 is 0. My yn is 44. Plus 2 lots of my middle numbers, so 26 plus 42 plus 48. And now I just type this into my calculator. And when I do that, I get 138. Let's just check that we've answered the question. So the question was, estimate for the total number of people who entered the mall in the first 4 hours. And if I go back to my original question, we know that P is in thousands of people per hour. So here in our answer, because we're looking for the number of people, we're going to say 138,000 people. Finally, explain how you would know that the trapezium rule in this case would give you an underestimate for the total. If we go back to our sketch of our graph, now I look at drawing the tops on my trapeziums. So let's really exaggerate this. So here's my curve, here's the top of my trapezium, and the top of my trapezium is always going to be below the graph. So in this case, we can say, explain how you would know that this would give you an underestimate. The areas for trapeziums we're finding are below the curve, the tops of the trapeziums are below the curve. And you just need to have a look at your sketch to see whether they're going to be below or above. The other common follow-up question to a trapezium rule is how could you make this estimate more accurate? And the narrower the trapeziums, the more trapeziums you've got, the better your estimate. So that's the two typical answers. Is it an overestimate or an underestimate, and how do you know? And how can you improve it? And we say that by using more trapeziums. And that's the trapezium rule.